Good morning, everyone. Today in this paper, we are going to discuss enhanced encoder-decoder model for precise text extraction. Let us discuss what is text extraction. Text extraction is a process of automatically identifying and pulling out specific data or information from a text source, such as a document, image, or a web page. It is commonly used in fields like natural language processing, optical character recognition, and data mining. Now let us discuss challenges in text extraction. First challenge in, although there are many different challenges, but these are three primary challenges. Handling noisy or unstructured data. Extracting text accurately from images, PDF or documents with poor quality, varied fonts and complex layout can be difficult. It is really difficult, different, although different methods have been proposed, but this makes the task challenging. Loss of context and meaning, which means extracting text without understanding its context can result in loss of meaning, making it challenging to interpret the information accurately. Then multilingual and handwritten text. Extracting text from documents containing multiple images or handwritten adds complexity due to variation in script style and character representation. This is one of the most challenging challenge in text extraction. In this slide, we will discuss our approach used in paper. So, what will happen is our approach consists of two methods, which is training and then testing model and then taking decisions. So, let's discuss training model, which is described at the left hand side of the diagram shown in the slide. So, in this, we have set of steps. You can see there are 6 steps. Okay, so training model consists of 6 steps. First, we'll take image from database. Okay, then we'll do cropping, detection, mm, and other things. Then we will normalize it. Whatever image is obtained at this phase, we'll normalize that. Then this is the approach which we have presented is, then we will use LSTM encoder, and then again at the next step we will use decoder, which is the core of our idea behind the approach presented in the paper. And then we'll do L2 normalization, and after that whatever image we have obtained is will be fed to the training model, and this will happen repetitively to thousands of images while we are doing the training. After we have followed all these steps and prepared a training model, we will have a testing model. Means we'll test this model on different unknown images which are not present in the database right now. So first we'll take the image, then same step, detection, cropping from the image, then same step, we'll normalize the unknown image, and then we'll feed that to LSTM encoder, and at the next step we'll feed that to LSTM decoder, and then after L2 normalization we'll have an image. Then that image will be fed to the prediction model. Specifically means we have used CNN to develop this model, and then Euclidean distance calculation will take place. And the more closer the distance is, the more closer the image will be mapped to text. So this is the core idea behind our approach used in the paper. And while we have tested this model, it has given us very good results as compared to other comparable models. So in order to means I want to repeat that we are only means claiming the novelty of approach in this paper. Means this thing has been done, but we are claiming that this approach is novel. Now we are presenting in this slide a flow diagram. Means how input image will be fed and how predicted text will be obtained. Okay. So, and what are the layers of our of CNN will be used to get that? Okay. So this is basically a flow diagram of testing model which we have discussed in the previous slide. So we'll give an input image, then that input image will pass through convolutional feature maps, and then at the third step a feature will be recognized. Then at recurrent layers, we'll have feature sequence, and then this will be fed to encoder-decoder LSTM. After that, text will be extracted. Means whatever text are present in the image will be extracted, and then transcription layer is responsible for converting or predicting text present in the image. So you can see that epping and other words are written. So epping twinned with epigen Germany. This we have to extract from the image. See, so all these steps will be required, and after that, pre-frame predictions will be obtained, and then after that, we have to just predict the sequence. So this approach has given us very good results, and we are discussing like this is the example how a single image means text will be extracted from the single image. In this slide we have compared our model with other models like CNN, and we have compared our model on the basis of accuracy, recall, precision, and F1 score. And as you can see that our model is very close to efficient detect D4 model, which is giving around means which is giving accuracy near to our model, and the data set we have used has performed means that data set our model has performed better than the other models which we have written. Means other models are performing on the same data set, and these are the score obtained. Finally we can say that, means I'm not saying that our my model is performing unexpectedly well compared to other models, but it is performing very generous and much better compared to well-known models. I will now like to conclude. The research highlights efficacy and resilience of the suggested OCR system in precisely extracting text from photos. The technology which we have proposed includes pre-processing, text localization, segmentation, character identification based on neural network, and exhibits exceptional accuracy and efficiency. The research introduced a new method of OCR using encoder-decoder LSTM structure. The ED-LSTM model utilizes the advantages of CNN for extracting features and LSTMs for recognizing sequential characters, which is main idea behind our research. The ED-LSTM system comprising a 7-layer CNN encoder and a 2-layer LSTM decoder, and has exhibited superior performance, as we had discussed in the previous slide, uh, than compared to well-known models. So that is all about our research presented in the paper. Now we can wait for 2 minutes for question answer session. Like basic question, one basic question can be asked, means how your model is better than other models. So I'm not claiming that I have done something which is very novel or very innovative, but I am just claiming that we have used LSTM encoder and decoder along with the CNN, which we can see that is giving reasonable results on the data set which we have used to verify the data. Although a lot of work needs to be done, means we have to test on other robust and other data sets, but in the whatever limited data set we had and other models were tested, we have tested our model on the same data set and it is giving reasonable results. That is why we are claiming that this our model can be considered as a means a new kind of a research approach as far as this domain of extraction of text from images is concerned. That is all for that is all. Thank you very much for considering our paper.